Hi, welcome to CSE114 Introduction to Object-Oriented Programming, and this lecture is on abstract classes. So let's have a look at a scenario. We want to write a program which involves geometric objects. So we can think of a geometric object as a very general or an abstract class where let's pay attention to this code that I have already written. I will explain that to you and then we will discuss about abstract classes. So we are thinking of geometric object which is very abstract, I will say, but it is still an important concept. So what do we have in this geometric object class? Geometric object will have a color. So whether it's a rectangle, circle, or triangle, we can associate an attribute or the data member called color. So for that reason, one of the data member is color. Its type is string, and as we should do, this data member has been declared as private. Then we have two other data members, like whether the geometric object that we have is filled or not. So that's a boolean variable which will determine whether this geometric object that you have is hollow or is it filled with any color. Alright, and then we have the third data member, which is about the date when this geometric object was created. So the third data member, date created, is of type java.util.date. So that's one of the class which is available with us, using which we can create date objects. So these are the three data members associated with geometric object. Now when we are thinking of geometric object, we cannot say anything more than that at the level of geometric object. Okay, we cannot say what area this object will have, but definitely it will have some area. Similarly, we cannot say anything about its perimeter, but definitely it will have some perimeter. Alright, so let's move on and let's look at this constructor from line number 5 to 7. This constructor is initializing the date. So this is something which will be common for all the geometric object. They'll have some date associated with those objects when we create those objects. So the first constructor is, you can call no arg constructor, because in the parenthesis for this constructor we are not passing on any value. The only thing that we are doing in this constructor is finding out the time when this object was created. Similarly, for the second constructor that we have, which is an arg constructor, it goes from line number 8 to 12. Here we do have the arguments for this constructor, like this, the color which is being passed on, then the information whether it is filled or not. So these parameters are passed on to this constructor, and in this constructor we will initialize the value for all the three fields or all the three data members that we have for geometric object, which is the date when it was created, the color, and whether it is filled or not. Good. So then we have some getter method, get color. Then we have a setter method which will set the color, and then there's a boolean method which will return whether it is filled or not. Then we have a setter method as well, which will set the field to whatever we want, whether we want to set it to be filled or not, filled as true or false. We can do that on line number 16. And then we have the date created. We have a get date created, which is a getter method. Using that we will return the date on which this object was created. And then finally we have a toString method. With this toString method will return the description of this geometric object. Then although we do not know how to find out the area of any geometric object, because this will depend largely on the geometric object that we are discussing. Like triangle will have a different area, A rectangle will have a different area, square will have a different area, so would be the case with circle. So these all the concrete subclasses that we will create from geometric object, they will have different area, but they all will have area. So what we can do is that we know about inheritance. We will create these methods like get area and get perimeter, but we don't know how to compute the area or perimeter of a specific object, so we will keep that as very simple, which is uh, you know its return type is double, name is get area, has to be public, and we're returning 0.0. Similarly, the get perimeter that we have for this geometric object class, we are declaring it to be public, return type is double, and we are returning 0.0. So this is not this is how we will have the methods and the data fields in geometric object. But when we need to create a class like circle, we are using inheritance here. So this circle class is extending geometric object. That means the circle class is being derived from geometric object. So you will declare its own data field which was not present in the geometric object. Right, so the circle should have a radius. That's the reason a new data field has been declared in the circle class as radius. And then you have no arg constructor, which we have kept very simple, nothing inside. That is possible. We have the empty body of the constructor. That means the radius will be by default initialized to 0.0. Then you have the other constructor, which is more meaningful, and in this constructor we are setting the radius to whatever radius user is passing on, or whatever radius we want to use for creating the circle object. Then we have a setter method for set radius, which will change the radius to whatever the program wants us to do. We have get area. Now this is the important thing right here. The get area method that you have written in the circle class will override the get area method that you already have in the geometric object class, which is the parent class of circle. Right, because circle has been inherited from geometric object. We are saying public class circle extends geometric object, which means we are deriving from geometric object. So the circle class is a subclass of geometric object. Similarly, we have written the get perimeter method also, which will override the get perimeter method right here in the geometric object class, which is the parent class of circle class. Then finally we have a print circle class, which if you want you can also write that as a toString method. Alright, then I should have a class, let me see, that should be a tester program which should run wait a second, geometric object class is right here. Comparable, circle exception, geometric object, there should be a tester program, test circle.java, I believe. This test geometric object, sorry about that, this is the test geometric object where we are creating two objects, GObject1 and GObject2. But before that I should explain to you about another class, which is rectangle class. So similarly, as we have written the circle class right here, there's a rectangle class as well, which is also derived from geometric object class, the parent class. And here for rectangle we should specify its width and height. Then there's a constructor here, the first one on the line number 4, which is a no-arg constructor that will initialize width and height to 0. And then we have a constructor on line number 5 which will initialize width and height to the value which the program can specify in the constructor call. So these values that the program or the tester program may specify the value for the width and the height of a rectangle. So the second constructor from line number 5 to 8 will create the rectangle of specific size as indicated by the tester program. Then we have getter method for width, setter method for width, getter method for height, and similarly the setter method for height. And we have the get area method and get perimeter methods, which are overriding the corresponding get area and get perimeter method in the geometric object class. That's the parent class for rectangle class as well. Okay, so what we have done, nothing new. We are just using inheritance that we have learned so far. And this is a meaningful case where uh, we can exploit inheritance. So that's the reason we are doing it. Now let's come to the tester program, which will make use of these two classes that we have defined. In fact, three classes that we have defined. Geometric object class, which is the parent class, and then the circle class and rectangle class, which are the subclasses respectively of the parent class geometric object. Alright, so what do we have here? On the line number 4, we have a perfect example of polymorphism, because the geo object that you're looking at, it has geo object 1 is an object whose reference type is geometric object, that's the parent class, and its actual type is circle. So that is perfectly allowed by inheritance. Similarly, for the second object that we are creating, geo object 2, its reference type is geometric object, but its actual type is rectangle. Okay, so geo object 2 would refer or reference to a rectangle of size 5 and 3. Good. Alright, so what are we doing next? Then we have done something interesting, so let me show you what all we have. In the line number 6, which I have split in two lines actually, the statement number 6 I should say, is invoking equal area method, right? So before we even try to understand what this output would be, let's look at the equal area method, which is defined from line number 15 to line number 18. So that's the thing that I have highlighted. Now let's see what this method is doing. It's static method, it's returning boolean, and is checking whether the area of two objects are same or not. Therefore, for this equal area method that we have, there are two arguments being passed on to it, object 1 and object 2. The type of object 1 is geometric object, and the type of object 2 is also geometric object. Okay, and then we are evaluating whether the area of object 1 is equal to the area of object 2 or not. And here we can make use of polymorphism, and it does not matter whether object 1 is a circle or whether object 1 and object 2 are of same type or not. Because of the way we are using polymorphism here, it is perfectly fine. You can invoke this method equal area like this. How is this thing interesting? Well, when you're invoking equal area on line number 6, then the geo object 1 that you have, its actual type is circle, whereas geo object 2 that you have right here, its actual type is a rectangle. Alright, so here when you are invoking equal area, then in geo object 1 and geo object 2, you have different kinds of objects. In geo object 1, you have the actual type of the object as circle, whereas in geo object 2, the actual type of the object is a rectangle. Okay, so we are using polymorphism in a very nice way. Okay, and that is only possible because we have this get area method defined in the the parent class, which is geometric object class. So if you don't define get area in the geometric object, then you cannot use uh, the equal area method in this way, which is very flexible. And this flexibility has come because of the polymorphism principle that we have. Okay, so if you are wondering, like, when since we cannot define the get area method at the level of geometric object, then why to have get area in geometric object at all? So to answer that question, this demo should have this test geometric object program of the class should help, because we are using we have defined a method called equal area, which will take the formal parameters of the type geometric object. So both the formal parameters that you have for equal area, they are accepting the parameters or the formal parameters of geometric object type, which is the parent class, and using that you can make use of the polymorphism. So that's what we have in line number 6, and the corresponding method which is defined on which is defined from line number 15 to line number 18. Okay, fine. Now how about the display geometric object invocation that we have on line number 9? So for that we should look at this method which is being written, display geometric object. Now look at the type of the formal parameter that we have. Again, this is also of the geometric object type argument. So its reference type would be of geometric object. Alright, so what is the advantage of defining display geometric object method with the type of the parent class, which is geometric object class? Answer to that is same, the polymorphism thing. So you can define this method once. Alright, so you have defined this method only once, and then it will depend on the type of the object that you're passing on. So if you're passing on a circle object, then in this method here, the circle get area would be invoked and circles get perimeter method would be invoked. Alright, again a beautiful use of polymorphism. Okay, so this tester program that you have is showing that thing, is in a way highlighting the usage of polymorphism. So let me run this program. Okay, so good. I mean, if you are these objects of the same area? No, they are not of the same area, right? Circle is of radius 5, so it will be pi r squared 25 into pi, whereas the area of the rectangle would be 18, right? So we do have the area here 78, which is the area of the circle, and whereas the area of the rectangle is 15. So these two are not equal. That's the reason you get the output as false for the statement on 6. And similarly, when you are calling a display geometric object for circle and the rectangle, you are getting the corresponding values right here. Okay, so good exercise, right? So it's a good exercise to brush up the concepts of inheritance and polymorphism that we have learned in the previous lectures. I did not teach you anything new till now. We just did some recap of inheritance and polymorphism. Now let me do something interesting at the level of geometric object. Right, so what interesting thing I'll do is I will play with these methods, which are the get area and get perimeter. So get area and get perimeter that we have at the level of geometric object are very abstract. Alright, so since these things are abstract, I should not even define the body of this method, right? So what I'm doing here is kind of useless. So is there some way I can totally remove this? So the answer to that is yes, I can do that. I can write it this way, But then if I'm writing it in this way, I should add another keyword which will be abstract. Alright, so wait a second. Okay, so fine, I need to fix few other things also. I'll fix that in steps. The message is that when you have a class which is too abstract, like the geometric object class, where you cannot define the get area method at all, you can define, because I was defining, but that did not look too good. So there is a better way of handling this scenario, where we will not even define the body, right? And what I'll say, I will declare these methods as abstract. Alright, so I'm saying that these methods that you have, get area and get perimeter, are too abstract to be defined at the level of geometric object. So I will remove the body, right? So initially I had the body like this. I mean, there was a little more in that body. I was returning some value. I will remove that. I'll just have what you call it, the header of the method, and I'll add the keyword abstract, telling the compiler that these methods are abstract for me. Now, when you have made any of your method abstract in your class, then you need to declare your class as well, public abstract. Okay, so because you have a couple of methods declared as abstract, I should call that abstract method get area and abstract method get perimeter, right? So I made my program little refined by removing the body of get area and get perimeter methods from geometric object, because the reason being these two are too abstract to be defined at the parent class level, but we do need them to be present here, because then only we can use polymorphism, right? Something that I have shown you already. Okay, and because you have at least one method in geometric object class that is abstract, so you need to change, you need to add the abstract keyword in your class as well. Alright, okay, now after that nothing will change. Alright, nothing will change in your rectangle or the circle class, and everything will work perfectly fine in your tester method. So let me run this tester method again. Alright, and things are same, but this is more refined now, and that's what we will learn in this lecture, which is about abstract classes and abstract methods. Alright, so what is an abstract class? So abstract a class like geometric object is an abstract class because I have abstract method in there. So how many abstract methods? I have two abstract methods in the geometric object class, which are get area and get perimeter. So the presence of abstract methods makes a class abstract. Okay, so don't worry, more systematic discussion will come as we go over the lecture slides, but I thought I should start with a demo and then we should discuss the details in the lecture slides. Now, a few other things that I should explain to you right here about the child class, which is derived from the abstract class. Now, it's the responsibility of the derived class to implement the abstract methods which are present in the parent abstract class. So, if you do not, let me comment it out, right, to show you something interesting. If I do not implement, sorry, this is not the one that I should be using. If I comment out get area method right here, then that is going to create an issue. The issue is that my class is not concrete yet. So when you say abstract, then there is another concept of concrete. So the class was concrete, it did not have any abstract method at all. But right now it has an abstract method. Why? Because circle is derived from geometric object, and in geometric object I do have get area and get perimeter, and these two are abstract. So that's the responsibility of circle class to override those methods, and if it is not, then this class should be declared as abstract2. Okay, public class. Okay, it should be public abstract class circle. Alright, so it's the responsibility of the derived class to override the abstract methods in the parent class. If the derived class fails to do that, then the derived class should also be declared as an abstract. Alright, so these are a few things we will learn in this lecture. So I am undoing all the changes that I had done. Okay, so let's hop over to the lecture slides. Abstract classes. Okay, now what is an abstract class, right? So let's discuss this systematically. In abstract classes, you will have instance variable and you will have defined methods which are not meant to be instantiated. So what do we mean by instantiated, right? So let's have a look at that. I'll use my pen. Can I change the color of my pen ink? I think I can. Alright, so here we go. So the abstract classes that we have are the classes which can have the instance variables, right? So we had instance variable in the geometric object class, if you remember. The instance variables were the date created, filled or not, and one more thing. It was date created, I believe. It was, let's have a look at it. Geometric object, it had color, whether it is filled or not, and the date when we created it. So in the abstract classes, you will have instance variables and you will have methods, right? But we will not use an abstract class to instantiate anything, right? So I'll explain to you what we mean. But anyway, I think I can explain right here as well. Instantiation means doing something like this. For the circle class, right, which is derived from the geometric object class, which we made abstract. So for circle class, we can do something like this. You can say circle C1 is equal to new circle, right? So what we did, we instantiated, we created an object from a circle, and circle was a concrete class. All right, but we can't do that for an abstract class. What does that mean? The way I finally changed my geometric object, I made geometric object class as an abstract class. So I cannot do something like this. I cannot write geometric object go is equal to new geometric object. Alright, so the point is that we cannot create any object from the abstract class. Alright, so although they will have constructors, but we will not use the abstract class to create the object of that type. Alright, so but we do need these constructors. So you would wonder, like, why do we need constructor when we are not creating any object from the abstract class? Then the answer to that is that we do need that, so that the derived classes may exploit those constructors. So the circle class, if you remember, we did not have any statement for initializing or creating the date created data member. We did not initialize that to anything. Why? Because that is something which will be done by the default by the constructor in the parent class. Okay, so all right, so subclasses will make use of these constructors, right? the constructors, they do exist, subclasses will have the constructors. This is a mean of combining. So you'd wonder, like, why do we need abstract class? So the reason why would we need abstract class is that so that we can write an abstract class which will have the common properties of the subclasses. Like the geometric object class that we created, it has some common features or common behaviors of the subclasses, like circle and rectangle. And similarly, you can also create another subclass of geometric object like triangle. So they do have all these common properties, like the color of the geometric object, whether these are filled or not, and on what date these objects were created. So all those are common properties which we can, or which we should abstract out in the parent class. And the parent class now is an abstract class because there are some methods with, like, get area and get perimeter, which are too abstract to be defined at the level of the parent class. And we will use the keyword abstract, right? So the declaration should go like abstract class and the name of the class, right? So that's how we wrote public abstract geometric object and then the body of the geometric object. All right, so now let's look at this UML. And in the UML, you should pay attention to the highlighted section. So the geometric object, right, which is our parent class, is an abstract class, and the fact that a class is abstract is shown with the help of the italicized thing, right? So that's the reason we have geometric object as italicized. That means it's an abstract class. Whereas the circle and rectangle, these are not italicized. Why? Because these two are concrete classes, whereas geometric object is an abstract class. Okay, then you have the color, field, and date created. All these fields as private. For that reason, you should see the minus sign before those. And then we have the types associated as string, boolean, and java.util.date. And then there's one more thing actually which I did not do in my demo. Whenever you have an abstract class, so let me do that. Okay, sorry about that. Let me do that and then I'll revisit. What I should do here, when you go back to geometric object class, now here the constructors are declared as protected, right? So a good practice is to declare the constructor of the abstract class as protected. Why protected? Because these classes won't be used, geometric object you won't use to create any instance of an object, right? So that I can kind of do right here also to give you some example. I discussed about it. We can't use an abstract class to create an instance of it, right? So what do I mean? I mean that geometric object, okay, GO1 is equal to new geometric object. I can't do that. All right, this is disallowed. All right, so look at this comment that I'll get. Cannot instantiate the type geometric object. Why? Because geometric object class is, let me take that in to the next line, abstract. Okay, yeah, so it will not work out. I should comment it out. Good. So back to my lecture slides. Okay, now now you should look at this thing. The fact that this thing, we have a hash sign before the constructor for geometric object. Reason of putting a hash sign before this constructor is that these are protected. So you should learn another rule about the UML, where if you have any method which is protected, then you should have a hash before that. So these two constructors are declared with a hash sign before those. Then you have getters and setter methods which are public, that's why you have a plus. And then look at get area and get perimeter again. So these two methods are also written in italicized way. Why? Because these are abstract. Alright, so abstract class names as well as abstract methods in UML are shown italicized. So that is how we will distinguish between the concrete method and concrete class and the abstract methods and abstract classes in UML. Then in the circle class, it's very straightforward. You added one more data member, which is radius. Then you have constructors, 3 of those, and then you have a getter, setter, and get diameter. Now another similarly for rectangle also you have 2 data members like width and height. Then you have few constructors, getters, and setters. Now an interesting thing you should have observed is that the get area and get perimeter methods are not mentioned in circle and rectangle class. Although these methods have been overridden in the derived class, but these methods are not shown in the derived class. Right? So methods get area and get perimeters are overridden in the circle and rectangle, but the superclass abstract methods are generally omitted in the UML diagram for subclasses. Right? So there is a reason why we did not write get area and get perimeter in the circle and rectangle classes respectively, because that's the way it works in UML. Okay, for abstract classes, or I should say for the abstract methods, we do not mention those abstract methods in the derived subclasses. Okay, so now what you're looking at is the demo which I used earlier. Okay, so let me see if I can get the color that I need. We'll use this blue color. So what do we have here? We need to define this class like geometric object as an abstract class. Now why are we calling this abstract? Because look at these two methods, right? So we have already worked on this example, so I won't be following every detail, but let's see. So color is string type, the field data member is boolean, the date created is of type java.util.date class. Then you have one constructor, the second constructor, and then we have bunch of getters and setter methods. We also have the toString method, but the most important thing is right here, these two methods. Alright, so these two methods that you have, which is get area and the get perimeter, at the level of geometric object are too abstract. For that reason, we define these two methods as abstract. And now if you have abstract methods in a class, then the presence of abstract method will make your class abstract as well. Okay, good. Let's move on to the subclass, which is circle. Now the subclass circle is being derived from geometric object right here. So you'll declare a circle just the way you have been doing earlier. So there won't be much change in the circle class. You need to you need to declare the data member for circle class, which is radius right here. Then you will write few constructors, and after that you will this is something which is must for you. Since your circle class has to be a concrete class, because unless it is concrete you cannot create an object of the type circle class. Okay, so what you need to do is that you need to override these methods. You need to override the method get area, and you should implement that in your circle class. After implementing only, your circle class will become concrete, otherwise it will be abstract as well. So I showed that in my demo. Similarly, you need to override the get perimeter as well and write your own implementation. Okay, alright, so let's move on to this other class, which is rectangle class. Similar to the way we had it in the circle class, you will have the data members like width and height for rectangle class, then two constructors, a few get and setter methods, and then the most important part right here, which is the implementation of the get area and get perimeter methods, so that it becomes concrete. If you fail to override any one of this method, then your rectangle class would be an abstract class, and you cannot use rectangle class to create rectangle objects. Okay, now this is the tester method which I used in my demo. So what are we doing here? Since it is important, so I will spend some time on that. We are using polymorphism here and polymorphism here. So geometric geo object 1 and geo object 2 are two objects. Their reference type is geometric object, which is the parent class, but the actual type is different. Geo object 1 object has its actual type as circle, and we are creating a circle object with the radius as 5. And for geo object 2, its reference type is geometric object, but the actual type is a rectangle of size 5 and 3. Okay, and after that we are invoking equal area method. Equal area method is right here. So in equal area method, its return type is boolean, which will determine whether the area of two objects like object 1 and object 2 are equal or not. That's the reason we are using equality operator here. Now the important thing is to look at the type of object 1 and object 2. The reference type of object 1 and object 2 is same, which is geometric object. That's the parent class. So because of that possibility, you can exploit polymorphism on this statement. Okay, and when you say object dot get area, then for our case, in our case we are passing on a geo object 1, which is a circle, and geo object 2 is a rectangle. Alright, so because of the fact that our equal area is defined on geometric object types of reference variables, we can use something like this. We can say object 1 dot get area, that will invoke the get area of the circle in our example, and object 2 is of type rectangle, so on the right hand side we will have the rectangle class get area. Okay, good. And then we have the display geometric object methods, and display geometric object method is similarly defined on geometric object, which is the parent class type, and we can use polymorphism here, and we are able to get the area and perimeter values for the circle as well as rectangle. Alright, good. So please, this is important, I'll say, and if you don't understand polymorphism and inheritance well, then yes, you will have tough time understanding this thing. Okay, so if you are struggling to follow this, then I will encourage you to go over the inheritance and polymorphism lecture first. If you follow that, then this should not be difficult, because what we are doing now is only adding the concept of abstract class and abstract. methods. Okay, so abstract method in abstract class, right? So now you will learn a lot of stuff which I was doing already, but now you will learn uh, the theory, I'll say, or the details about it. Abstract method in abstract class. So an abstract method cannot be contained in a non-abstract class, right? So if you have an abstract method in your class, then your class will be an abstract class. If you want to make that class non-abstract or concrete, then you should not have abstract method at all. So if you followed the way I started this lecture, the first thing that I did was I made get area and get perimeter as abstract. So when I did that, then I was getting a message from the compiler which was forcing me to make geometric object class as abstract. Okay, so that's the same thing. An abstract method cannot be contained in a non-abstract class. So presence of an abstract method will make the class abstract too. In a non-abstract class, in a non-abstract subclass, extended from an abstract class, all the abstract methods must be implemented. Okay, if not, then the subclass will be an abstract too. So we did that, right? We created two subclasses. We created circle subclass and rectangle subclass, and in these two subclasses we implemented or we overrided the get area and get perimeter methods in the parent class, which was the geometric object class, and that was an abstract class. If a subclass of an abstract superclass does not implement all the abstract methods, then the subclass must be defined as abstract, right? We have seen that. When I commented out the get area method in the circle class, then you must have noticed that compiler was asking me to declare circle class also as an abstract class. Okay, so what else do we have here? An object cannot be created from an abstract class, right? So I have shown that as a demo. You cannot use geometric object class to create geometric object. Okay, so an object cannot be created from an abstract class. An abstract class cannot be instantiated using the new operator. So we are adding more information to help you out with this concept. So you cannot have something like new geometric object. You cannot do something like this. Okay, this is not allowed. But we can still define its constructor, right, which are invoked in the constructor of its subclasses. So for geometric object we do have some constructors, and those constructors are used to initialize the data members like color, isField, or date created. So the constructor for geometric object are invoked in the circle class and the rectangle class. So please do that, right? Make sure that this is happening. Okay, a subclass can be abstract even if its superclass is concrete. I will mark this with multiple stars. This is very important concept, right? Which you may find strange for the first time, but let's look at that. So in the example, right, let's start with the example. The example that we have done, or the demo that I did, here the parent class was abstract. The geometric object was an abstract class, and from that abstract class we created subclasses like circle and rectangle, and those were non-abstract or those were concrete. So in most of the cases that you come across, you will have a subclass that is concrete and the parent class is abstract. But it is possible to have a subclass which is abstract but the parent class is concrete, right? So parent class is concrete but the subclass is abstract. So the example is the object class, right? So if you remember, now this relates to our previous discussion. When we learned about polymorphism, then in the polymorphism we also learned that there is a parent class, object class, which is the ultimate parent class in Java, and all the other classes are derived from the object class. So this object class is a concrete class, but the geometric object class that we declared is an abstract class. Right? So this is an example where your parent class is concrete, but your subclass like geometric object is abstract. So that is possible. You can have it. Alright, so now this I believe is the most important slide, which so the most important point is right here, but before that let me cover this point. You cannot create an instance for an abstract class using a new operator, but abstract class can be used as data type, right? So what does it mean? You can use the abstract class as the reference type. You can, it's data type, or if you want I can also say as a reference type you can use it. Alright, so you can use abstract class as the data type, or we can call that as a reference type. So this is perfectly fine when you have the abstract class on the left hand side of your assignment. You can have geometric object C is equal to new circle. That's perfectly fine. And even the most interesting thing is right here, where you can have geometric object on the right hand side also, but that should come in the context of an array. Okay, so if you want to create an array of geometric objects, so that is fine, you can do that, right? Why? Because here also you're using geometric object as the data type. But this is perfectly fine. You are using geometric object as a data type, right? So this is also fine. You can use an abstract class to create an array as well. Alright, so this is a case where you'll see that geometric object which is an abstract class is coming on the right hand side also, and that is coming with the new keyword, but only when you are creating an array. Okay, for a single object it will fail. It's only for an array that it is working out. So in the following statement in which we create an array whose elements are geometric object type, this is correct. That is perfectly fine. So the interface topic I'll take in a new lecture, because I think it will be a little intense, although it will be short, but it's better if I do the lecture on inheritance in a separate topic. So it's a very important topic which I just covered. I will encourage you to please make sure that you understand this concept and do the demo as well. Thank you so much. I'll see you in the next video lecture.